Alright, well, a warm welcome again to the cute Tetris tutorial. Where we left off last time, we just got our piece on the screen, and when we move it over to the side, we have a collision check that spits out the word collision, which you can see kind of just at the bottom here. And if I go to the right, collision, and then if I go all the way down, I should see collision again. So, oh, and also if you hit the up arrow, you get your rotations. Cool. So, what I'll do is, I'm actually just going to restrict movement of our piece based on the collision. So, quickly over here, I'm just going to more or less just add some if statements. Alright, so we have our function, tetramino key press event, and it takes in a key event. So when we hit that left key, what we want to do is actually use this collision check variable here. And to do that, we're just going to do like an if statement. So if collision check maybe I'll do something like that. Oh, whoopsie. Yeah, there we go. We're just going to actually just reverse, or more or less just like artificially shift it back every time we have a collision check on the left. So to do that, I'm just going to do tile right, and then we'll just return. I think that can go. I'll just try this out real quick. So if I'm going to the left, yeah, see it has that collision flag going off, but yeah, it's essentially stopping us from moving, because every time we want to move the one way, we got to move back. And similarly, I'll just do that, more or less copy and paste this for the right key. Except this time I guess we're gonna subtract. And we'll actually do this also for the rotation key, which is, if you hit the up arrow, we rotate plus 90 degrees. So except if we have a collision, we're going to take, instead of set x, we're going to do set rotation. Is that the right function? Yeah, set rotation. And then instead of our x variable, we're going to do rotation, and we're going to subtract 90. So yeah, basically the idea is like whatever we do in this key press event, we're just reversing. Of course, you could also just do like else if, and then like include that in your condition, assuming that there's no collision, then do the key press, but I don't know, I just found this a little bit easier. And finally the down key. So once again, if collision check, set y. Right, set y. I think that should be good. So I'll run this again. And right now I'm moving the down key just to get in the middle of the board. Move it over to the left, and I can't go left. Move it over to the right, and I can't go right. And now I'll go down. Can't go down, and if I hit the up arrow, I'm okay because I haven't collided. But if I hit it now, and yeah, see, as I try to T-spin down, I guess, I can't do that. Alright, so in the game of Tetris, assuming that you're familiar with the game, you would know that each piece moves down on its own, like sort of like a gravity rate on each piece. So how do we do that? What we're going to do is make use of a few more features in the Qt framework, particularly the signals and slots. So I've included a few little libraries here. So there's the Q timer library, because our movement is going to be a product of time. Basically we're going to shove the piece down once every second. And the first thing we need to do is set up our signals and slots. So to do that, we're just going to hop into our header file here, and I'm just going to make this class inherit from another library, the QObject library. QObject. So we got two that we're inheriting from, the QGraphicsItem group, which we spent a lot of time talking about in the previous videos, and the QObject. And one little thing we got to do here is set up this QObject. So we basically set up that line, and then we're going to add a new function. But that function is not going to exactly be a public function, it'll be a public slot, which will make a bit more sense shortly here. So public and slots. And I'm just going to call that the function move down, and we'll declare it. Alright, refactor. Okay. Okay, so similar to before, we had our code for the down key. We're going to do pretty much something similar, where we're going to set the Y position like that, and of course that only happens if there is a collision check. So when does this function get called? So we're going to actually call it up here, and I have a little integer variable, so int time, and this is 1,000. This is meant to represent 1,000 milliseconds, and we're going to call our QTimer. So QTimer, similar to before, we'll make a new QTimer. Alright, and now we're going to connect. So the connect keyword is pretty important for the Qt framework, and I'll just actually pull up the web page here. So we're looking at our documentation. This is actually from version 6.7, but I think it's more or less the same. So the connect keyword, it gets the first object, a signal, and then connects it to the second object and its slot. So our first object is going to be the timer, right? So that's going to be our object that gives a signal, and the signal will be timeout, right? So we're just looking for that particular time, and then the object that we're connecting to is actually this, right? So we're going to use the this keyword to say that this signal is going to connect to the Tetris piece class that we just made. And the slot, right, the slot that it's going to hit is going to be that move down function. I'll just close it like that. Cool. And then the timer, we're going to use the built-in function start, and then the time will be time, right? So it'll be we'll start the time at 1,000 milliseconds, and then, restart kind of thing. And let's see if that works. Hopefully I don't look like a fool. And look at that, it's moving down on its own. And I'm just going to speed it up a bit to see if it stops where I expect it to. Perfect! So really this QTimer is still going down, but because of the nature of our move down function, where we say if it has a collision check, we're going to shove it back up. So that kind of idea. Alright, and with that I think I will stop the video there. Thank you again for joining me. In the next video we're going to generate more Tetris pieces, set a board, and hopefully we'll have time to show you what it looks like to delete a line when you make the full Tetris board go across from border to border. Until next time, take care.